Hi, Professor. This is Shubham, and this is our final project on social data mining techniques. This is our group 12, and uh, we are three guys Jeffrey Joe, Shubham Thaplial, and Divyansh Bhardwaj. We have assigned the topic weather, where we took a weather data set, and the name of the data set is hourly energy demand generation and weather. From this data set, we can see that we have around 1,78,397 rows and 17 columns. Apart from that, coming to the data description, we can see that it contains data of different cities of Spain, like Valencia, Madrid, Bilbao, etc. And we have the temperature, the minimum and the maximum. Apart from that, we have other attributes such as pressure, humidity, wind speed, etc., where we can predict the most humid region, the most rainy region, and the most snowy region. We have some of the attributes such as DT underscore ISO, which represents the date and the time. We have the city name. We have the minimum and the maximum temperature. We have the pressure and the humidity and other factors as well. So why we choose this data set? This data set we found was interesting, educating, and challenging. It contains 17 columns about the weather of the country, which is Spain. This data represents the various type of parameters like humidity, wind speed, etc. for different cities with changing time. This data was collected from five major cities named Valencia, Madrid, Bilbao, Barcelona, and Seville. This data shows the changing climatic temperature in various cities of Spain. Now I'm handing over the next part to my teammate, which is Divyansh Bhardwaj.
Hello, Professor. Now coming to the data cleaning part. So I selected the DTISO, which stands for date and time, as a polynomial variable. And after that, I remove duplicates, and by selecting all the attributes, after that, with the some attributes which is not useful, like for rain 1 hour, rain 3 hour, and snow 3h, I remove the low quality data. After this operation, by selecting each specific column, we found that the values that we rapid miner cleaned up were either duplicates or nulls. Now coming to the knife base. In knife base, first I used the retrieve attribute after cleaning the data. Then I selected the select attribute, and in select attribute I filtered the all data. After that, I took the set role, and in the attribute I took weather main, and for the target I used label. After splitting the data in 70-30, I performed the knife based operation with the Laplace correlation, then apply model and the performance, and then after running the process, as we can see the accuracy here 99.96 in the performance factor. In the and after that, in the simple distribution, as we can see the class clear as a 16 distributions, then class clouds, and so on. We choose naive base because it is simple to set up predictions, the probabilities of various classes based on the various features, and is particularly helpful for very large data sets. As a result, we employ naive base to forecast the weather for the precision as 99.96. Now I will hand over to Shubham Thapliar.
Thank you, Divyansh. So, coming to the linear regression, where we have used the retrieved data set after cleaning, we use the select attribute, we use the subset in the attribute filter, where we took temperature and wind speed. We set the role as label, and the attribute name is lab temperature here. We splitted the data into 70-30. We performed a linear regression, and when we run it, we can see the attribute which is wind speed for the coefficient, the standard error, the standard coefficient, tolerance, and so on. From here, we can also see the temperature, the prediction of the temperature and the wind speed, how is it flowing. We can also see the root mean square error here and the squared error. So basically, the process, the explanation is that the value of one variable can be predicted using linear regression analysis based on the value of the another variable because one item depends on another. Dependencies are crucial to this technique. The dependent variable is the one we want to be able to forecast, and independent variable is the one that is used to forecast the value of the another variable. And from this, we can see the correlation RMS, which is 7.985, and the squared correlation is 0.013. Now I'm handing over to Jeffrey Joes.
Hello, thank you for that, Shivam. Hello, Professor, this is Shafi Ghose. So I'll be showing my logistic regression that I've done. I've chosen to do logistic regression on cloud job and use it as my normal to numerical to binomial variable that is for doing the logistic regression. And I've set it as the label. I've split the data into a 70-30 split, which 70% goes to logistic regression, the other goes to the applied model, which finally goes to the performance operator, which gives us the final result. And here we can see the predictions, and there's a very high accuracy for predictions. There's about 96.71%. And here we can see the information checks. And the reason I'm using this logic regression is because using logic regression, we can predict come to binary conclusions like yes or no. And based on previous observations of data or a particular value, the fixed value can also be referred to as a statistical analytic approach. Here, the clouds are they're converted to binomial, and the logistic regression is run. And I've got the accuracy of 0.617. Now, moving on to part D, uh, I've used made the naive Bayes model, and you have done the same thing as Shivam as Dinesh has done with this model. And once I run it, here I can see a very high accuracy of 9.87%. And if I go here to simple charts and I select chart, uh, small, here we can see the curve here. This is uh, the simple distribution where it's comparing the snow and rain. And here in the visualizations, we can see a scatter bubble chart. It depicts the weather features based on the different cities. And the minimum temperature, we can also see that the minimum temperature is constantly changing. And with the changes in cities and are indicated by the different colors. And here we can see that Seville has the maximum temperature recorded, and Barcelona has the minimum so far. Then we have a bell curve as well. As you can see, it's almost a perfect bell curve. That's because of so that proves that this has a very high accuracy as well. Now I'd like to hand over back to Shubham.
Thank you, Jeffrey. Hi, Professor Shubham again here. So the party comes out to be, we need to compare the results from the auto model. And this is my auto model. So basically, let me just tell something about the Rapid Miner. Rapid Miner Studio Auto Model is an add-on that streamlines the creation and validation of models. So, so basically, this is the model where we can see the cluster, and when we run it, we can see that it's running.
prediction chart prediction chart हो सड़ी के
We can see the prediction chart as well, and in the correlation we can see the correlation. We can also see the correlation by weight, which is the temperature is the maximum followed by others. Coming to the last, we have we can see this the visualizations, and we can also compare the model from the auto model and the manual design, which are as follows, which is reporting speed, flexibility, wide use, greater accuracy, etc.